My name's David Owen, and I work for Temple Incorporated. I've been employed there for 12 years now, and I'm part of their technical service team. And today we're going to be talking about our Siemens M60 controller. So the ports on the M60, we have our USB port here on the left side. That can be used for upgrading firmware versions as well as saving the intersection files. Down on the bottom here, you've got your A, B, C, and D connectors. Then over on the right hand side, you've got a status light. You've got some communication ports, FSK, SDLC, and RS-232, as well as your Ethernet port. The controller comes defaulted out of the box as a standard 8-phase controller, and if any changes are needed to be made, the controller is disabled by default. I'm currently in the utilities menu here, and if you ever need to escape out from any screen, you can press the escape key, which will take you back to the home screen. Talking about the access of the controller, we'll go 2 for utilities, and you'll see here 1 for enable access. We'll choose choice 1, and to enable the access of the controller, it's 4 zeros. And then you would press the enter key. Now access is enabled to the controller, and you can make any changes necessary. Some customers have custom access codes that you may need to know while on site. The controller comes default out of the box, but we always recommend starting from a known good. You can default the controller by going to 2 for utilities. Then you can choose choice 4, load save data. Then choice 1, load defaults. From this screen here, you see the cursor is blinking beside the SPaT wording. If you press enter, that will load the defaults. Or if any changes need to be made for cabinet environment, you can scroll down and you can change from TS2, New York State, ITS, ATC, etc. After defaulting the controller, next would be the cabinet environment. Okay, the Siemens controller comes default out of the box. And for any reason you need to make a configuration change to what cabinet type it's going to be installed in, we can choose choice 2 for utilities, 4, load save data, and then 1 for load defaults. From this screen here, you can default the controller by pressing the E key for load default, or you can scroll down and change current software options from TS2, New York State, ITS, ATC, etc. There's a whole host of choices there. Today we're going to be talking about this traditional NEMA TS2 environment. Next we're going to talk about mapping phases. From the main menu, choice 3 will take you to your phase data screen. And within this menu, we've got vehicle data, recalls, detector information. If I choose 1 here, vehicle data, within this screen we have our vehicle timing screen, dynamic max, recalls, and bike and AWS timings. Choice 1 takes you to your traditional phase timing screen where you can adjust minimum green, max times, yellow and red times. Once you have your phase timings set up, we can then look at detector data to begin configuring those detectors for each phase. Choice 7 for detector data takes us to our configuration window. You can see we have each detector listed individually. I'll choose choice B here for an overview. This gives you the breakdown of each detector and their assignment by default. Detectors 1 through 8 are phases 1 through 8, and they're all vehicle detectors by default. If I go back to our individual screen, let's choose detector 1 for example. I'll choose choice 1 and then vehicle detector 1, and within this screen you can change its phase assignment, you can add extension or delays, and a whole host of other options. Alright, now we'll talk about getting the controller set up for fixed time operation. Out of the box, the controller does not come with any recalls programmed. For any reason, if you need to set up some recalls from our phase menu, we would choose 1 for vehicle data, 3 for recalls. And from this screen, you can set up single call, minimum recalls, maximum recalls, soft and bike recalls. Typically, you would see recalls on your main phases 2 and 6. Another reason why you may want to add a recall would be if you had a faulty loop and you weren't receiving actuation, you could set up a recall for a particular phase from this menu. In a TS2 environment, we're almost always using actuated detection. There are other ways to cycle the controller, whether that be fixed time or coordination plans. And some reasons why you may want to run fixed time would be in a downtown grid area. Let's say you have multiple intersections close together. There's no real reason to run actuated detection. We can run fixed time. So that means we're always running phase 2 together, we're always running phase 4 together. That really helps flow in tight areas. Some other types of operation will be coordination. We see this on main corridors that have smaller side streets. The timing plans are configured in a way to where they run on certain splits, so they run the main streets for a certain amount of time, then they release, and if there's any type of detection calls on the side street, they would run the side street. Then they would come back to the main street. Okay, now that we have our phase timing set up, some of the next things we could look at would be programming preemption. So anytime we're in a screen here on the M60, if we need to go back to the main menu, you can either choose the F or the escape key to go backwards, and you just press that multiple times till you get back to your main menu here. On the main menu, real quick, you see up in the upper left the SPaT version number. This is obviously a Linux controller here, so anytime you're curious on what version of SPaT you're running, you would see that in the upper left-hand corner. Okay, so we'll talk about preemption next. From the main menu, that's choice 7. And this lists all our preempts. You see each have a number out beside them. Number 1 is preempt 1, 2 preempt 2, etc. And that used to not be the case, so just be careful on which number you're pressing and which preempt you get into. We'll look at preempt 1 just as an example. So within preempt 1, you see some additional menu choices. Under choice 1, miscellaneous, this is where you can go in and set your exit calls for any particular phase that you may need to service after the preempt is complete. You can set to exit to those phases. You can also set preempt duration times, preempt extends or delays, and any type of lockout features that you may need to program during preempt 1. If we go back one level, another important screen for the setup would be choice 3, vehicle status. Within this screen, this is where you can actually program what phases you want to run during that preempt. Typically, we just have preempt set up per approach, but if you need to have multiple phases running during that particular preempt, like in a railroad routine, you can choose those phases and then choose how they would cycle down below, whether that be versus actuation or by minimum or maximum recall. Next, we'll talk about priority control. From our main menu, we can choose choice 8, and that takes us to our priority data screen. We offer up to 12 different priorities. Let's look at priority 1 as an example. The basic of setting up TSP, we need to know what detectors we're using for our priority detectors, and that would be in choice 1 under our detection screen. Down towards the bottom is where you would go in and assign your advanced detectors. If you had any B detectors, cancel detectors, or checkout detectors, you could input those as well. The number field there, that's wanting to know the detector number, the SPaT detector number of that particular priority detector that you're planning to use. Simply enter that detector number in the screen there and hit the enter key. Let's go back a level. Next, we need to choose the service. This will be assigning the phases to prioritize here. So this example, I'll just set up phases 2 and 6. And that's just by putting a 1 in under those columns. After that, we need to tell the controller where we're going to output our transit signal head. This is where you can assign the output of that signal head for what particular overlap, and also give it a type. Last thing we need to do is we need to assign the level of priority that we're planning to use. We offer 3 different levels: minimal, partial, or full, and that is set here under the level cursor. We can also enter additional data from this menu, and if you press the help key when the cursor is in any field, it will give you an explanation if it's some type of abbreviation. So here, this is where you can enter the time of service desired, time of estimated departure, and time to live. And all of those fields are in seconds. If you need to set up an Ethernet connection to the controller, that can be done very simply from the main menu. We'll choose 2 for utilities, 6 for configure ports. And under this configure port screen, this is where you can set up not only your IP addresses, but any type of serial COM if needed on this controller. Let's look at choice 4 for IP addressing. Within this menu, we can set up our IP address, subnet mask, and broadcast from the screen. You can also give the controller a unique host name. They all come generic as the ATC 2070-Siemens, but if you would like to name this as your intersection, you can simply do so from the screen. The only thing you need to take note on is you cannot set your gateway from this screen. You need to go back 1 level and choose choice 5 for network configuration. This is where you would set your gateway type and then enter that in the fields below. If you need to enable your controller for SPaT, you can do so from the main menu by choosing choice 2, then choice 6 for configure ports, and then choice A for SPaT addressing. Here you can set the destination IP where the controller will send the SPaT address to. You'll need to hit the E key to unlock the menu. You can enter your SPaT IP in. If you need to change your destination port, you would do so here. And then once you've done that, you need to put a 1 in to enable it. After that, you press the E key to exit, and then SPaT traffic will be sent to that IP. You can also send SPaT to multiple IPs at the same time. Now let's talk about dynamic max. This is a function of the maximum green time that some agencies like to use, where you can set a max value and you may not want to use that value as a hard set time, but more or less build up to that value. And that's hence the name dynamic max. So from the main menu, we can use choice 3, phase data, and then go into choice 1 for vehicle data, and then 2 for dynamic max. You can see your phase numbers across the top here, 1 through 8. So you would set the dynamic max value for that particular phase. Let's say we want 30 seconds under phase 1. I'll hit enter. And then down below that is how much time you want to step up to reach that maximum value. And this is in tenths of a second. So keep that in mind. Anytime you see a /10 next to a value, that would be in tenths of a second. So if we want to step up 5 seconds each time, we'd put a 50 there. And so that's going to keep adding 5 seconds until we reach our dynamic max of 30 seconds. Another useful screen that may be worth noting would be from the main menu, the active status screen. And from here, if you choose choice 1, it takes you to a submenu with a lot of different data here. But I recommend ring timers, and then you can choose choice 1 for ring 1 and 2. You can see that displayed here at the top. This shows you your current phases on and next. If you have any recalls programmed like we do here, we have all 8 phases under recall. You can see those. But if you were running actuation, you would see C's across here for the calls. And then same for your pedestrians. If you had any PED inputs, PED calls there, they would show up. And then the H and O is holds and omits. So your ring timers, you'll see those counting down. This is what you would be seeing out in the field. If you were running any type of chord plan, it would display the pattern down here as well. Another useful menu is choice 7. So that would be the 1-7 screen from the main menu. This is a similar view, but it just shows you the colors of each phases across the top for your vehicles and your PED signals. And then if they have any calls, the calls would be listed down below there under V call and P call. Same with your overlaps. If you're using any overlaps, those will be displayed down here at the bottom. Back to the main menu, you may notice the F keys going across here. These are some what we call hotkeys, and this is what this 16-line display has on the bottom 8 lines. You can have these set up for favorite screens. If you have favorite screens you'd like to navigate to, they can be set up here and assigned to your F keys. So that is what those are for there on the bottom. So we know in this NEMA controller we have our default of our load switch mapping. Phase 1 through 8 is typically load switch 1 through 8. But if that's ever needed to be changed, we can do so from the main menu by choosing choice 4 for unit data. And then choice 9 is our output mapping screen. This is where we assign load switch number to phase number. If you need to make any changes, you can do so by the whole load switch itself, or you can make pin by pin changes if you need to do so that way. Some customers like to run flashing yellow arrow compact mode, and they would need to go in and make some pin changes to drive the flashing yellow arrow out of the PED channel, or a whole host of other reasons. But you can change the load switch mapping by pin or by the load switch itself by pressing the E key there. If you need to do any troubleshooting with your M60, you can do so by looking in the reports of the controller. From the main menu, choose choice 0. And within the reporting screen, we've got COM faults, system detectors, detector faults. Choice 3, let's look at detector faults. This would be useful if you had a detector that was faulting out. You can go in and see what that detector may be. Let's see, for example, like the time that it may be doing it. That could help you track down a potential problem if it may be happening during a certain time of day every day. Back under choice 4, your alarms. Any input that's done to the controller, whether that be by keypad or by remote through the central server, is logged here under the report. So you can go back and basically see any change that's been made to the controller is stored here under the alarms report.